All right, and there we go, and we're live. And good evening tonight. The next vBrownBag broadcast in the Domain 1.0 series, part 2. Let me just clear this. Designing highly available, cost-efficient, fault-toleration, scalable systems with Tim Carr as our featured presenter. Tim.
Yay, Tim.
Yeah, how's it going? Thanks for having me. And I apologize in advance. It's so hard to follow such a great radio voice. My goodness.
That's what the double C's have in common.
So a couple of quick housekeeping notes.
I'm sorry, sure. Quick notes, get in on the conversation at vBrownBag, at BrownBag LATAM, at vBrownBag EMEA, and at vBrownBag Junior. Twitter hashtag crosshatch vBrownBag, professionalvmware.com, brownbags, APAC every other Thursday, 10 p.m., and ZDT. Where's that?
New Zealand time. That's a joke from Alistair.
EMEA, VCP, and V Series, Tuesday, 7 p.m., BST. The Latin American, Thursday, 7 p.m. Pacific. U.S. Wednesday, 7:30 p.m. Central, 8:30. Us. Tonight's guest, Tim Carr, at Timmy Carr, www.timcarr.net. And tonight's hosts are Chris Malhoit, myself, and Chris Williams at Mistwire, http://mistwire.com.
Hello, everybody. All right, let's kick it on over to Mr. Carr. And away you go, sir.
All right. Well, let me figure out how to share my PowerPoint stuff here because that's what everybody's wanting to see. And at this point, I believe we should be close to good to go. Give me 2 seconds to hit the play button.
All right, we can see your screen. Oh, now we can't see your screen.
Give me just a second. How's that?
Still can't see it.
Nope, nope, still down.
How about now?
We had seen it previously before you changed something, and then it went away. So.
You know what? I was using the slideshow function, just hitting play in my PowerPoint presentation there, and that didn't work. That's not all that big of a deal, though. If you can see that, is that all right at the moment?
No, we cannot see the presentation at all. It's we just have the splash screen.
Give me 1 second. How about now?
Yeah,
there you go.
There we go.
We got it.
All right, that's perfect. Sorry about that, everybody. We're all technical people, so we have to get over our technical difficulties, right? So just a quick introduction about me. I'm an Ahedian, a small data center consulting company in the Midwest, headquartered in Chicago. Spent about 3 years at Ahead, helping customers with consulting, so on and so forth. I'm pretty deep in VMware tech, and like everybody else, I'm here to learn the AWS technology. That's why I've decided to be a part of this vBrownBag thing for this wonderful sprint that we're doing. Besides IT, I do a little bit of running with my German short-haired pointer who needs a lot of exercise. I play a little bit of trumpet, and I enjoy being told what to do around my house by my fiance. So beyond that, I'm a little obsessed with my Starbucks unsweet green iced tea. So if you ever see me walking around, you probably see me holding that cup. I apologize. It's kind of a habit. Just some things to go over here. I included this from Nick's presentation earlier. I think we should probably have this in every presentation. These are some of the things that you can go check out to help you on your path towards the AWS Solutions Architect exam. I like all of these, and the one that I wanted to add to this list is actually a video series called acloud.guru that you can go to and do online. I find that video series incredibly valuable. I find that everybody learns differently, right? I mean, it's a great platform. The videos are concise about every service, and frankly, I think it's worth every penny. It's not incredibly expensive to buy the video series. That you can buy a 5-pack to get you through the whole gamut. Chris, what's your take on that? Have you had some success with that? Have you used it as well?
Oh, absolutely. So the very first thing in my study notes is a review of all of the materials that I used, and my primary source was Ryan Cronenberg's acloud.guru. I mean, I absolutely loved that entire series.
Yeah, I think it's invaluable. I encourage everybody to pick that up. I don't think that as a community, with the number of events that we have so far lined up here, we have the ability to cover everything. So I encourage you to check out all of these resources, check out all of the white papers. Definitely a cloud.guru. Get with that, get on it, and do it. It's worth it. This is the basic blueprint for Domain 1 that we're covering today. If you watched last week, Nick Collier from Ahead got on, and he kind of talked about some best practices around AWS architecture, and then kind of gave a tour of each of the services that the more relevant services. We certainly don't have time to cover them all, but he did a pretty good job of covering all those. Make sure you have a chance to review those. Today, where we're going to be focusing most of our time, though, is we are, this is Nick's presentation. Today, we're going to talk a little bit about HA versus cost and RDS versus EC2 as far as databases go, and really what that gets into is, trade-off decisions and so on and so forth when you're doing architecture, right? And so we're going to talk about how Amazon has said that they want you to consider architecture when you're thinking about AWS as a cloud platform. And we'll get into that. We'll also kind of mishmash that with how we've typically done architecture within IT and talk about a few of the differences. And so let's get started and kind of jump into this. One other review slide that we had from last week that I want to make sure that we cover talks about regions and, more importantly, availability zones. So let's just do a quick review of what region is and what an availability zone is, because everybody really needs to understand this when we start talking about high availability in the platform. So what we see here in the orange/yellow circles are the regions within AWS, and this is where you can choose to spin up services and so on and so forth. Each of these regions are comprised of at least 2 availability zones. Those availability zones are a data center. And the important thing to understand as far as your service is concerned within AWS is that the availability zones have high, like a high throughput, high bandwidth type connectivity between the two of them. So and high throughput, high bandwidth, but also low latency between the two of them, so that services running in those data centers are very close to one another and can react within milliseconds of one another. So truly designed so that you can scale your services within one region across different data centers, which are the availability zones. So once again, this kind of covers, you can see the region here, comprised of at least 2, but a lot of times more availability zones within your environment. It's really important to kind of understand and grasp that topic when we start talking about HA. So let's dive into what Amazon RDS actually is, because it's kind of asked to cover RDS. Well, RDS is, as you know, a blue dot that kind of looks like it's playing Minecraft. So that's what it appears to be. Actually, it's not. It's a managed database service, right? And it's important to understand what that means when you say managed database service. It's truly a database in a box, right? And what we mean by that is you buy that service, you have the capability of connecting to that service, that database service in a box, and it's running one of these predetermined platforms for you. In this case, you got MySQL, MariaDB, Oracle, Microsoft SQL Server, and PostgreSQL. We've got Oracle twice in here because I thought that was super extra important as a typo. So what does that mean, though, from an application owner perspective, right? Well, so what that truly means is that RDS is going to provide you with what you need at a bare minimum, which is that database service, right? And it's a relational database service as well. So there are different types of database platforms out there. Amazon certainly has other database platforms out there, but this really is the traditional, you can think of it as almost an Excel spreadsheet type schema database service where you're looking at columns that are related to one another, right, within a database. So that's what we're talking about. What does it do for you? Well, it runs that engine for you, which is actually quite hard, right? If anybody's ever sat down and tried to configure even one of the air quotes easier type of database platforms, you'll know actually getting the configurations that the database vendor wants you to get done correctly on your virtual machine is actually quite hard. Like even for people running Microsoft SQL Server today, whenever I'm jumping in and looking at an environment for somebody and they say, hey, what's wrong with it? And, I look at how they've configured their disks and so on and so forth. It's almost always some configuration best practice that's in there that's been missed that ultimately ends up causing performance issues. Okay, that's great. With Amazon, they take care of that for you. They've squared it away. RDS covers all those best practices for you on the back end, and things are just going to work. Now, you give up some things when you do that, though, right? So what they're going to do for you is they're going to manage your backups for you, and they're going to manage the patching for you, too. And that's important because you really don't get an opportunity to have so much say in your patch cycle, or so much say in the version that you get to run. There are times when Amazon will come through and say, "Hey, we got to upgrade," and that's that. And so you have to be you're kind of giving up a little bit of control in your environment. I guess the other thing that's kind of nice is that you get to scale. The instances are resizable, right? Which is kind of different than if you don't go buy a server or something like that in your data center and put it in, or if you were to buy an EC2 instance and install a database on it yourself. And like we saw on the previous slide, just jumping back there, I mean, if you look at the list, Oracle being on there twice because it's a super big hitter, but you can see that all of the big databases are really kind of supported in this model. If you can't get the type of support that you're needing out of RDS, the chances are your application is just a little more sophisticated and you've been painted into a corner by running some commercial application that's an off-the-shelf application, or it's the kind of thing where you just have needs that are beyond what Amazon's capable of doing, and then maybe you need to look at something like a database platform. So, Chris, so far is that on point as far as what you're seeing with the RDS service? Have I missed anything? Why else would you leverage RDS in your world? What are your thoughts there?
For our particular use case, I mean, it as always. As an architect, the answer is, and it always frustrates people, but it depends.
Mm-hmm. We're going to get into that. Oh yeah.
Yeah, the customer use case, who they have on site, their level of expertise, the kinds of systems that they're running. It's always an it depends answer. If you pointed me at a particular customer, then I could speak more eloquently to it. But we actually did have a question that popped up in the interim. Alphonse was asking, this was back when we were talking about A Cloud Guru. Have you seen, reviewed, or looked at the Linux Academy AWS series? I hadn't, so I wasn't able to speak to it.
No, I hadn't either. But I am of the opinion that you can never have enough learning. I'm sure it's good. I've seen other Linux Academy stuff, and it's usually right on point. So I can't imagine that it's not going to be good. I would say check it out, and more importantly, share it. If you enjoy your experiences with it, post it out there on Twitter. Your experiences with the hashtag vBrownBag. Hey, I found Linux Academy AWS course. It was great. Check it out. Let's share that kind of information. I certainly haven't checked it out yet. I really just focused on the Cloud Guru and some of the other online resources that I was able to find at the time. But definitely share.
Nice, very cool. And Ankit is saying that he reviewed Cloud Academy and he said that he liked it. They have hands-on labs too with Learning Path. He is right now tweeting a 25% off link. Thanks, Ankit. Appreciate it.
Yeah, Ankit, that's awesome. Thank you, man. All right, so briefly we talked about, what do you get in the box, right? Managed patching, managed backups. Okay, well, part of that involves maintenance windows, right? So, RDS maintenance windows give you the opportunity to halfway have control when a database is modified by Amazon, right? And this can be a couple of things. This can be related to software patching, or it can be related to actually scaling your database instance class, right? Maintenance windows are generally 30 minutes in length. If you don't select one, you're assigned one. So it's kind of interesting. I would say select one. And the other thing to note here that they don't really talk about in the documentation, but is kind of oh well, that's totally obvious, is that your backup maintenance window and your actual database maintenance window need to be two separate times. So think about that for a second, right? One thing you might want to consider is getting a clean backup of your environment prior to saying, okay, Amazon, now you can proceed with your maintenance window. So one thing that I always like to do is making sure that I have my backup window precede my actual maintenance window of an environment. Let's see here. Oh yeah, backups are going to pause I/O in non-multi-availability zone deployments for your environment. So that's important to understand. That means your RDS service will potentially have a blip while a backup is out there and running. Now there's a way to get, and that's on non-multi-availability zone deployment. So the answer to that is don't do that. Give yourself a little more capability and use a multi-availability zone deployment. It's as a matter of fact, it's how we can add high availability to RDS. And really what it does, what a multi-availability zone deployment does, is it creates a replicated standby instance in a different availability zone. But there's another word up there that's kind of important. It's synchronously replicated. We're going to talk about synchronous and asynchronous in a second, but it's important to understand here that we're talking about maintaining the state of individual rights to your database here. One thing that happens on one side will be replicated to the other side before you are responded to, saying that that right actually occurs in your database. So under the covers, a failure of a primary node within your multi-AZ deployment will cause RDS to fail over to the standby node without any end-user intervention, right? And these happen for a bunch of common scenarios, right? So loss of network connectivity to a primary, loss of availability in an availability zone, a problem with the storage on one side of your RDS environment. That will cause an automated failover, which is a nice feature to have, and something I can't really think of, in my mind, like if I'm trying to architect for high availability, this is definitely a just do it kind of sort of scenario. There are other options out there as well, though, and we're gonna talk about that in a second. During failover, it's important to know that the primary node is actually not accessible, so there is that blip, right? So we can get around that blip for our web applications if we want to try to be 100% available in our environment by adding something called a read replica. But that doesn't get us write capabilities for our application. It's important to understand that a read replica is something where we can actually just leverage a replica of the database as close to real-time data as possible, but in another site. But it's not writable, and that's why we call it a read replica. And let's just talk about that for just a second. So a read replica is a separate DB instance, right, from our primary RDS instance, where we have an asynchronous replication. So in the slide here, I've got all caps, async equals lag, and what that means is that data in that database may not be completely up to date with what you have in your primary site. Remember when we talked previously about the multi-site synchronous replication earlier? That's actually real-time, replicated, and you're going to have consistency within availability zone 1 and availability zone 2. With a read replica, it's potential that you will not have 100% consistency within your database. So it's important to consider the type of app that you would want to leverage this for. There are scenarios where this would certainly be appropriate. Like if I was having a, I don't know, something like an Amazon.com, for example. You want to go on, you want to buy stuff. Amazon perhaps would update their catalog with items that would be available, right? Well, for performance, it's okay if maybe not every single item is available to you 100% of the time. What it would not be appropriate for would be the current stock of those items, right? You would want to have a real-time feed of, is that item available? And so on and so forth. So that's an example of, in one scenario, the current stock where you would want to use something like synchronous, and then the other side of it, the asynchronous thing, where for performance you might want to show people, hey, what you have in the store, right? So a couple different use cases there, and a couple of different ways to talk about availability within RDS. I've gone through a whole swath of stuff here. I realize that. We have any questions so far, Chris? Are we chugging along okay?
We do have one question, and actually a comment too. For those that are getting ready to take the test in the near future, I would recommend looking at the number of read replica instances that you can spawn off of an existing database. It's the number of async models that you can have. That was something that came up. And a question from Brian Watson is, I did not think Amazon managed backups. Only if you configure it to use Glacier, right? They don't magically do backup management, right? Right?
Well, so Amazon, you have potential to do backups within your environment, and it's something that is configured with you. You do have your backup window as part of RDS, and that is something that you can configure. As far as automatically doing it, I'm not sure if it automatically does it, but I always configure backups in my environment, so that's why I'm not sure. That's part of my standard process. Chris, what are your thoughts there?
Mine too. You turn it on, and you then start having backups. In terms of automatically doing it, no. I mean, you have to specify, yes, start backing up this instance. Brian, if you're playing with like the free tier, then starting doing your backups would actually start incurring cost. But since I'm playing with the free tier, I don't. So I just I leave mine turned off as well.
Yeah, my MySQL database is being backed up currently in AWS, and I just remembered it being a, hey, turn this thing on, and you have your access to your backups.
Oh, Brian Krausen just spoke up. It will do it automatically in RDS. They're like snapshots. You pay for the storage of each snapshot.
Yep. Yeah, it's kind of what I thought, but in my experience, so I run my blog on AWS, and my MySQL is RDS, and going back to backup for me was as simple as just going back to the last backup in the chain. I honestly couldn't remember setting that up. I knew it was really easy, and I was like, backups, yes, go. So, I mean, there you go. So, one of the things that we wanted to talk about as well on today's spiel, I guess you could say, is kind of architectural trade-offs. And to get into that, I wanted to first discuss kind of how I think when I'm designing a solution. Like I said, I kind of come from the virtualization background, and I don't think from a virtualization background, from a DBA perspective, from a developer perspective, I really don't think there's any difference in how you need to think. I think there's just different semantics, and so because this associate level cert is kind of the beginning cert for a lot of people when it comes to things, I wanted to make sure that everybody had a level playing field with how to start thinking on how to design architecturally. So for me, that starts with the total fundamentals, right? Ramps, right? This is standard stuff. Everybody's done this, but you got recoverability, availability, manageability, performance, and security. Now, I'll tell you right off the top that Amazon kind of takes a different view for how they want you to see this just a little bit, but I wanted to tell you how we see this in typical, or how I've always seen this, and this is one of the acronyms that I've always used to kind of hit all the big points, right? So let's kind of talk through how we kind of map this to your environment, right? So when we talk about those aspects, recoverability, availability, manageability, performance, and security, we want to talk about mapping them to every aspect of your infrastructure, right? Your compute, your network, your storage, all of those things, right? So each one of those components needs to be manageable, available, recoverable, have performance, be secure, right? And I think it's kind of easy to see why we want these things, right? Security, target, right? Performance, well, our app has to perform well or we're getting calls at 2 a.m. in the morning. Manageability, well, I actually have to be able to manage that thing. How can I configure it? So on and so forth. So it seems obvious, but I wanted to give people the opportunity to just consider each of these things. And this is a really good tick box, I find, for being able to find flaws in designs or, you know, maybe flaws in your environment today. Take a step back. Look at what you're running. Does it hit all these things? You know, it's always a good exercise. Now, let's talk about recoverability. That's a function of ramps. We talked earlier about two different options for recoverability within an environment. One being leveraging multi-AZ type scenario, being able to synchronously replicate in an environment, and the other was talking about read replica, right? So I think that's kind of key when it comes to recoverability. When you look at availability, right? When you look at RDS, right? When you look at Oracle, PostgreSQL, MySQL, and MariaDB, on the back end, to make these things available for replication, all the white papers that I've found say that they use Amazon Tech, whatever that is, for replication within the environment. Now, Chris, do you know anything deeper about this, or is that as deep as you get there as well? Because all I was able to really find there is Amazon Tech.
No, this is as far as I've gone as well.
Okay. All right. SQL Server options, they use SQL Server mirroring. So anyone out there knowing, you know, hey, how does Amazon do these things for Oracle, PostgreSQL, MySQL, or MariaDB? Pipe up, let me know. But, you know, as far as availability, we talked about this is how we can make our database a little more available. For manageability, right? So this is an interesting part where we start talking about trade-offs. So we could use an RDS instance, right, for manageability. You know, what we get when we leverage RDS is we kind of get placed into a box. For example, if you're leveraging SQL Server, you get up to 4 terabytes of storage on that SQL Server instance. That's kind of one of the limits that you might look up for that environment. You need more than that? Well, you're going to need to figure out how to get beyond that within your environment, all right? It's not, the RDS isn't going to make that happen. So one of the trade-offs that you might need to figure out in your application is, okay, how can I do this? Am I going to have to build an EC2 instance where I'm managing storage the old way and where I'm actually provisioning ones and so on and so forth? Or can I start to look at an environment where I can actually leverage sharding or something like that within an application? Sharding being where I actually have, you know, multiple database instances where I'm storing data, and then my app is aware of what data is stored where. You know, one other gotcha that I found for SQL Server in particular, because that's one that I've worked with, is that storage type or capacity is not able to be changed. And I don't know when this is, when or if this is changing, but for today, I wasn't able to change capacity or type after I instantiated my instance with an RDS, and so that can be kind of a manageability bugaboo with when you choose RDS. So it's important to ask yourself, does this solution match what I'm going to need to do in my environment? Performance, right? So, you know, one of the things we talk about is when we talk about databases is data set, and can we actually get everything in there? So in general, with RDS, we try to allocate enough memory so that the working set of our database actually resides in that memory. You can leverage CloudWatch, and you can look at read.io when you look in CloudWatch. That number for read.io should be small, but more importantly, it should be stable. So your read.io shouldn't be jumping all over the place when you look at your server. If it is, you might want to scale up your RDS instance and scale it up to the point where you can try to stabilize that number if possible. Now, these are all architectural trade-off questions. One thing that you should ask yourself is, as you scale up your environment, is my performance of the database sufficient, right? In the end, you need to have some sort of key performance indicator. Maybe it's like the number of requests your app can accept, or the amount of throughput of your app, so on and so forth. But you need to have and identify a key performance indicator that allows you to measure as you scale up within your environment. And then let's see here. Oh yeah, performance considerations for multi-AZ deployments. Right. So remember when I talked about multi-AZ deployments needing to write in both sites before acknowledging their environment? Believe it or not, a single non-multi-AZ deployment can theoretically serve a faster write than a multi-AZ deployment, right? Because what's actually happening under the covers is you're waiting for consistency from that other site. So it's important to understand those sorts of things. That said, regions are architected, to give you very low latency. So you're really not too hamstrung by that right within an environment. So I would look at that. It's important to consider when you click the multi-AZ button. There are performance implications to doing that for your application, and you may want to consider if there are right performance implications. There are some other ways to ensure availability and recoverability of your environment if needed. These are all architectural trade-off decisions and part of the conversation that you need to have with your customer or with your group when you're actually architecting these solutions. Also, provision IOPS always pretty good with for RDS. It's always important to be able to control the amount of I/O that you can expect. And the great thing about provision IOPS within your environment is that Amazon does adhere to an SLA, a specific SLA around how they are meeting those provision IOPS and how well they meet those provision IOPS. I like that from a database perspective, because a lot of times the database is the back end of your app and it has to function at a certain type of level all of the time. And then security. So here's this, in my mind, this is one of the big reasons why RDS yes for me, right? Roll your own. You're back in the, and I don't want to say it's wrong to roll your own in EC2. It's certainly not. There are a lot of really good options out there. But that said, if you do roll your own, you're out there managing access to your database and database services just like you were on-prem. And that's not necessarily a bad thing, but why do that if you can use RDS and just leverage IAM? IAM's elegant, simple, and can be leveraged from the command line. Can be scripted incredibly easy, and it's just built in with RDS. And for me, it's a complete thing of beauty. And I think that right there in a nutshell is, when it comes to security, it's, hey, IAM, RDS, done, match made in heaven. So, we did a quick covering of how I look at architecting a solution through leveraging something like ramps. When you talk Amazonian, if that's a word, when you look at AWS, they want you to consider cost as well. They think that that's very important, and I agree. I frankly, for all the Ramps fans out there, and no, I didn't say Los Angeles Rams fan. That's Ramps fans out there. I think what they're missing is that ultimately cost is a huge driver in any solution, and the reason why people leverage AWS is to get closer to that line of what you actually need to use versus what you buy, so that you can actually go to market with your application. So, I think what we do with ramps is that we take it one step further by saying, hey, it needs to kind of be cost efficient, right? And Amazon kind of defines how they look at their methodology by saying, we need to be able to create systems that are secure, reliable, high performing, and cost efficient. And that's how they look at it. And they've got a great white paper that kind of covers those sorts of things. I got that link there. That'll be in the slide deck later. I recommend reading that white paper. It's good. There's that one, and there's one other one that we're going to cover today. But when we talk about optimizing for cost, we really talk about right-sizing computing, right? And that's important. You know, I think the cheapest instance type able to run is the right choice a lot of times, right? But in some cases, and this is why you need to right size and then also measure performance, right? In some cases, using a fewer, larger, more costly instances may actually be the better performance or better performing environment, right? So what I recommend, like I said before, is benchmark different configurations. And I think the beauty of AWS is that you get to do that. It's pretty cost effective if you're spinning up and spinning down and trying things. And I like trying different configurations, right? I like saying, hey, what does this look like if I bump up the amount of memory that I have in my RDS instance? I did it when I was playing with my blog, and I actually found that, you know, no, I didn't need to spend any more money on this database. I could actually go smaller, which is really nice. I was actually able to show that though by benchmarking in my environment. So you know, it's really useful. Make sure that you're right sizing in your environment, but keep in mind, cheapest isn't always the best. You want the best performance by monitoring key performance metrics. Storage selection for cost, right? I think when you look at applications, everybody's like, I want the fastest stuff possible. If you go into a data center today, everybody's like, I want all-flash storage. Well, the fact of the matter is you probably don't need all-flash storage for, you know, your old logs, you know. There's probably a better place to put that stuff, right? So be mindful of what you're putting where. Be mindful of when you're using provision IAPS. Be mindful of when you're using, you know, even magnetic disk. I've seen really good use cases out in the wild of people who will put things on magnetic storage within their environment that just don't need the performance, and they're saving a ton of money. That's huge. Also, and this is a big one, right? And I'm not sure about where this is actually covered within the test rubric, but I know it is in certain points. But it's important to remember that S3 in particular offers many different storage options, and they have different costs. There's standard, there's reduced redundancy, and there's standard infrequent access. Now, Chris, talk with me about experiences with the exams. I know that I seem to remember this coming up and in conversations about it. I think that you need to know, like when I look at this screen, right, first of all, know everything here for storage, right? Like you need to know magnetic, general purpose, provision IAPS, that's a given, right? But S3, yes, that's out there as well, right?
Yeah, it is, yes.
Yeah.
So the know the number of nines for both redundancy and durability. For each of the S3 offerings, standard reduced redundancy and standard infrequent access have two different sets of metrics and two different sets of numbers. So when you're studying, know what those are.
Awesome. And how are we doing on questions? I took a breath there. I know I talk fast. I got to get through these slides. We got to roll.
Nope, we're good. We're good. You're rocking.
Awesome. Awesome. And then another thing when we look at optimizing for cost is we talk about elasticity, right? And this is something that I'm a big fan of. I'm a huge fan of leveraging you know, auto-scaling groups for workloads when possible, but then I'm a huge fan of potentially leveraging Lambda for running compute instead of actually running a service on a server, right? There's a lot of good ways to leverage Lambda these days to rethink about how apps are actually going to be deployed. You know, purchasing options. Now, I'm not going to cover these because we're actually going to cover these at a later date. I would just note, as far as databases go, because they wanted me to kind of focus on that today, I think reserved capacity is a key area for database workloads. The chances are you have to have your database, so if you know you have to have your database, it's not bad to figure out what you need and pay up front and save a few bucks, right? So optimize there as far as database services go. And then, you know, I would say one thing that's always important to know is make sure that you know trusted advisor in case that comes up. You know what that is. It's a service that allows you to optimize your environment. It's in there in the dashboard when you log in. I believe it's a green one. Am I right, Chris? Am I on there? Is it the green?
I'm actually logging in right now to find out.
Well, no trusted advisor. It does some nice things around optimizing for cost, optimizing for performance, and also looking at availability metrics, I believe.
Right. Yeah, basically know that it saves you money. It proactively helps you to take a look at your cost, and it helps with your expenses.
Okay, so we talked a little bit about ramps. I wanted to jump back there. I apologize for jumping back and forth through slides, but I want to tie all this together. We talked about ramps. We talked then about how we can add cost to ramps, right? And what we end up with is the AWS well-architected framework within our environment, right? And this is a white paper that you need to read as well. You need to read this because this is how Amazon says you should look at services and how services should be aligned to best practices within your environment. Basically, it's a series of questions that cover all of those bits of ramps that we talked about, but it divides them into what they call 4 pillars in their environment. Now, one thing that we say up here is the word best practices, and I put best practices in quotes, right? This is just a personal, I guess, annoyance of mine. There's no such thing as a best practice. I know that everyone wants you to think that way, but really, as an architect, your job is to design an environment that meets customer requirements, assumptions, and constraints. That's your job, right? It just so happens there's a fundamental set of things that seem to always be true, and I think what I want everybody to take away from this is just because it seems to be true in all cases doesn't necessarily mean that it's a best practice for every implementation. So please try to think outside of the box as an architect and ask yourself, do I really need this? Even at times when you think it's the type of scenario where, sure, it's got to be that way. No, it really doesn't. And this is, that magnetic disk idea keeps coming back into my head. That was an opportunity where people were like, well, we have to use SSD, right? Well, no, they didn't need to store the type of data that they were storing on SSD in this environment, and they needed to, kind of think outside of the box as far as what they were doing with the database type of workload that they were working with, or the workload that they were working with in this case. Okay, so we talked about ramps, but Amazon wants you to look at ramps as kind of what they call their well-architected framework, right? And that's based on 4 distinct pillars: security, reliability, performance efficiency, and cost optimization. You'll have to excuse me. Security, reliability, performance efficiency, and cost optimization, those are the 4 pillars. And I think the thing that you can clearly see is that, wow, this really isn't any different than ramps. They've added cost optimization, and they've put some other fancy words around reliability and performance efficiency. Yeah, that's right. Reliability, that kind of comes with availability, and that also comes with, can we recover, so on and so forth. And then performance efficiency is, how well does the app perform? I mean, these are the same things. It's really just trying to simplify it. I think that's what Amazon's trying to do with this 4-pillar approach. Now, when we look at general design principles from the AWS well-architected framework, they're really simple. It's stop guessing at capacity needs, test your systems at production scale, and ultimately lower the risk of architectural change, and then automate to make architecture change easier, and eventually allow for evolutionary architectures within your environment. This is all, like I said, from the white paper here that you'll see within your within the slide deck here. I recommend everybody read it. key points, key for understanding how Amazon wants you to architect in your environment, and good for beginners to start thinking about how we're going to work within the environment. Now, Chris, as far as exam goes, do they, are they asking a lot of, do they get to the point where they're actually asking questions about these sorts of things? I don't think they're actually asking you architectural questions, but I think they're asking you questions that, I think they will ask you questions about each of these areas, certainly, correct?
Yeah, it's not what are the four design principles. What is this? It's here's your scenario. What are the decisions that you? I mean, it'll ask you to make a decision, and it'll if you've one of the things that I would recommend is the AWS the two PDFs that you put up there. Absolutely read those through completely and get to know them. The cloud architecture, cloud best practices, security best practices. The VPC connectivity options, all the PDFs that are basically in there for the exam prep are PDFs that you want to read and know, because the questions basically come right out of there, but not word for word verbatim. It's the do you get the context of it? But you're absolutely right.
Yeah, I think you hit the nail on the head. It's not do you know what the four pillars are? It's do you understand how to function within the four pillars and answer questions related to them? And I think that's key when you're thinking about it. So it's more about, and the reason why I've tried to go back and give examples of each of these sorts of things in the presentation, and we'll do some more of that, is because I think that's kind of how they're going to drive questions within the exam, right? So the security pillar, most importantly, security everywhere. I mean, that's one of the core tenets of AWS. Firewall and security controls on every resources, every server, load balancer, networking subnet. Think of them as I trust nobody, and so on and so forth. And frankly, Harry the cat trusts nobody either. I apologize for the meows in the background. Enabling traceability, right? You need to be able to log and audit everything that happened within your environment. And then automate responses to security events, right? So this is how you're going to enable security within your environment. These are important things to know, and these are truly right out of that PDF, and they'll give you example questions that you might ask yourself of your environment that are actually pretty helpful in figuring out if you've got all of these design principles covered. Focus on securing your system, right? And that's really what the security pillar is about. Because you have Amazon covering, infrastructure basics for you, you get to spend less time worrying about your infrastructure as a whole, and more time worrying about, hey, how do I make my application as a whole secure? And that's important. That's what your time should be used for if you're actually deploying. And then ultimately, automate security best practices. And one of the best examples that I can leverage, that I can give you here is, hey, baseline image for all your virtual server images, you want that baseline image, right? And you need that to be locked down and very secure. So what you do is you create that custom baseline, and then your entire infrastructure is then defined from that template in your environment. And we're going to get into EC2 in a later event. This is, like I said, a little bit early on, and I wanted to get an idea and grasp some of the concepts that we're going to be talking about a little bit later in the series. Reliability pillar, right? And this one's key. This is something that I do consulting for on-prem customers who run their on premises data centers in different sites and so on and so forth. And I tell you, this is one that a lot of customers say that they can do, but they really can't do. And the beauty of having cheap and plentiful infrastructure is that, yes, you can test your recovery procedures within AWS. Costs should not be considered an option here, and nor, frankly, should infrastructure resources be considered a problem within your environment. So make sure you have a recovery procedure and that you've tested your recovery procedure. After you've tested your recovery procedure, figure out how you can automatically recover from failures, right? And I've got all caps, great Lambda use case here, right? So if you're monitoring key performance indicators in your environment, and you know that, maybe a query on a database might be resulting in, some challenges here, maybe you need to do something within your data set, so on and so forth, and you can use a Lambda function to help you with that, get after it. That's how you need to be thinking about mitigating, and then automatically recovering from failures. Attempting to build and scale horizontally with cloud services. That's key. Scaling up is certainly something you can do in your environment. The instances can get huge. There were some ginormous instances that were just announced recently that they've looked at for running big time customer applications in AWS, and I mean terabytes of memory and so on and so forth. Those bad boys are really, those bad boys are really expensive. Do you know what the cost is on those off the top of your head? I mean, like it was bananas. Like the hourly cost on it, they might as well have just put an emoji of a banana next to the cost because it.
Hold on, I'm going to spin one up right now just to see.
That's your bill, my friend. That's your bill.
It's not in the free tier. I don't know why. That's so weird.
I can't imagine why it's not in the free tier. Yeah. No, I mean, it's so attempt to scale horizontally. And the reason why we want to do that is because that allows us to leverage stuff like auto-scaling more efficiently in your environment. If you can run a small service on a small instance and your application can be built to scale wide, then you're in a great spot for AWS type workloads. And then finally, stop guessing at capacity. There's no reason to guess at capacity. There's all kinds of metrics that you're able to collect within your environment. If you don't have all the metrics you need, there are a lot of really great tools out there like your New Relics and so on and so forth that will actually help you get into your application so that you can actually start monitoring transaction times of your application, your web app from user click all the way back through the database. So there's not really a good excuse. There are tools out there to really get you really great, deep, and robust monitoring. So capacity should be the easy part in this environment. Amazon's provided plenty of availability there. And then performance efficiency, right? So Amazon has done a lot of really great things with stuff like RDS, right? But they've also done great things with like media transcoding and machine learning, and those are really hard problems to solve at scale, right? And Amazon's done a really good job at doing those. If Amazon has already done it for you, and this is the way that I look at almost every service that I'm thinking about deploying in AWS. If Amazon has an offering for it, I am going to try to figure out how to utilize it. And that is going to be my de facto answer for it, because why waste the technical hours trying to become an expert at something or trying to hire somebody who's an expert at something if somebody can already manage it for you and you can just pay to manage that. That's performance efficiency pillar. Also, be global. AWS is global. Think about, does your app need to have global reach or regional reach to get your data closer to customers? Closer data to customers equals better performing application for end users. It's physics ultimately. The packet has to get down the wire, and the shorter the wire is to the end user, or in this case, the shorter the distance the user is from the cell phone tower, or so on and so forth. The better performing the app's going to be, right? And so it's important to think about how to deploy your app down the road in a global aspect. Finally, leveraging serverless architecture. I don't really like the name serverless. It's just kind of where we've ended up as a tech community. There are definitely servers running those things, and I think that's the thing. That's the thing to look at when you talk about serverless technology. Tools like Lambda and so on and so forth. Those are actually running on servers. Your Python code is executing in a container on Amazon's platform. That in itself means that you don't have to maintain that platform, and frankly, you don't have to maintain any bit of that OS. You just have to execute your code. So that's bonus, right? And then experiment, right? Because infrastructure is so cheap, and we can gain efficiencies in our environment because infrastructure is so cheap. We gain those efficiencies by testing out scenarios on how to make our app better, right? And that's all a part of the performance efficiency pillar. And then finally, cost optimization pillar. I like to transparently attribute expenditures, period, within my environment. Even if you're not doing showback or chargeback today, if you're a big organization, you need to know what app is costing you money. Down the road, somebody is going to ask you that question, so leverage tagging there. And then use managed services to reduce TCO. I can't say enough about stuff like RDS. You should always be looking at these things. Finally, trade CapEx for OpEx. Spin up, spin down, use auto scaling, and then pay for only the resources that you need to consume. This is one of the core tenets of cloud, and it seems obvious, but it's something that you need to remember and consider within your environment. You know, these last two are pretty obvious. Economies of scale, Amazon's got a lot of stuff. They're going to pay less for their lot of stuff than you would if you try to build your own data center. And finally, cost optimization allows us to stop spending money on DC ops. I think there'll be a lot of arguments from enterprises who'll say, hey, we're always going to have DC ops. Yeah, I agree, but I think data centers are going to get smaller, and certainly Amazon's cost for running at scale has shown that they continue to get cheaper and cheaper over time, which is only another reason to go to the cloud. So, you know, I tried to hustle. I think I'm about 5 minutes before the hour, which gives us time for questions. That was a lot. I talked super fast. I'm sorry. You might need a stopwatch next time for me.
What are you talking about? That was fantastic. You nailed it.
It sure was.
Well, thank you. So I know, do we have any questions out there? Or are there any other things that we might want to talk about?
So the answer to your question, Tim, was $3,970 per hour.
3,900. So let's just call it an even 4, because that's what it is.
You know, it's $30
they
off or
Walmarted
whatever.
that. They're like $9.99. No. That's $4,000 an hour, kids. Wow.
Yeah, that's the list price. You can talk them down.
Yeah, I mean, I guess if you're buying that server, you're going to be talking to someone eventually anyways, right? Someone's going to knock on your door. So, yeah.
Yep, exactly. Ankit has a question. Chris, you want to run with those?
Oh, yes, I do. Ankit says that you mentioned about you were unable to modify capacity for the MS SQL Server. However, aws.amazon.com RDS SQL Server details does mention about scale. Are we missing something here, or am I reading it wrong?
I think what I was getting at there is, most importantly, I know that, and maybe I'm wrong. Maybe I'm wrong here. Maybe the service has changed, and so I apologize if the service has changed. Most importantly, but what I was definitely trying to convey there is that if you were to go with a standard, like a standard SSD type workload versus a provision IOPS, I think that you have trouble moving between those two disks within the service, and I could be wrong there. Please fact check me. Thank you, Ankit. I appreciate it.
And to that point, even if you look at the notes that I made on the website for when I passed the exam, literally back in April, the numbers have changed dramatically even since then. To the point where people are actually in the notes down below correcting me with the new numbers, and literally the services are changing every single day. One of the things that I would recommend is if you guys use Stitcher, subscribe to the AWS Tech Podcast. It's about 12-15 minutes. I listen to it every day when I'm driving into the office, and it goes over all of the newest changes and offerings that that AWS is coming out, and it's hosted by two really cool guys down in Australia. It's called the AWS Podcast. Right now, they're on podcast episode 141, and they were actually talking about the X1 this morning and the elastic networking capabilities, the new offerings. So it literally changes all the time, Ankit.
I don't see any other questions.
Can't change storage. Mr. Krausen has responded, can't change the storage on SQL Server after it's launched due to the extensibility limitations of Stripe storage attached to Windows Server. Have to create a new instance and export the data from the original one. Now you have to pay for the storage you aren't using by allocating more storage. his next comment was, this was accurate as of a few months ago. It could have changed. That was my understanding as well, Brian.
Yep.
So, but Ankit, to everybody's point here, it changes nightly. So dig into it yourself as well. Cool. I think, yep. We are clean. We are clear.
Yeah, no
Thank you.
others.
Tim, that was fantastic, dude.
Tim, it
Well,
sure
thank you,
was.
everybody. I wish I had more demo, but we're just not there yet, unfortunately. I mean, we're still at the basics. So thank you, everybody, for covering some basics with me today. I appreciate it, and thank you, vBrownBag podcast or webinar team. This is awesome. I followed this from the virtualization days. I'm so thrilled that we're covering other things. I mean, this is great. I'd like to see AWS. I'd like to see some Azure stuff out here as well. This is amazing. I love it.
And that's, so we've got, you know, another month and a half of AWS stuff lined up for the cert, and then we're gonna be spreading our wings, as it were, to cover a lot more stuff in the future. Cool. And Alex says it was wonderful. Thank you, guys. So huzzah! All right, I'm gonna click the stop recording button, and we have stopped recording.